Hello everyone, I'm Jacob Kaufman, I'm the Nerd on the Street, and today we are taking a look at systemd timers. Alright everybody, so if you've done any sort of Linux administration, you've probably heard of something called cron. There are a number of different daemons out there, programs that can run on your computer, that exist to run other programs at certain times. Say you want to run a program at the same time every week or every 24 hours. Maybe you're running some kind of cleanup task, rotating log files. In my case, I've been using timers recently because I've been setting up a system where every Thursday night I've been doing a live stream. And I've got a stream server that I use. It's an RTMP restreaming server, and it's also an HLS server. And I spin that server up before the stream starts, and then after the stream ends, I destroy the server. It's a DigitalOcean droplet that I'm using there. And I can use DigitalOcean's API to actually create the stream server and set it up the way I want it before I start streaming, and then after I stop streaming, I can destroy that server, just remove it from my DigitalOcean account, and that way I only pay for the couple of hours that I'm actually using the server. I don't have to pay for the full $5 a month that it would take to keep that server running all the time. So I've been using systemd timers. I set up a system on one of my other Linode servers that every Thursday, an hour before the time that I start streaming, it calls a script that spins up the DigitalOcean server, so it's ready for me when I get off of work and I'm ready to start streaming, and I don't have to worry about doing that manually because it's on a timer. Whatever the case is, if you want to automate a process running automatically, there are a number of different cron utilities out there that you can use. However, today, with most desktop Linux distributions shipping with the systemd, I almost called it init software, but I realized systemd does a lot more than that. Freedesktop.org refers to systemd as a suite. So with most desktop Linux distributions shipping with the systemd suite, you don't actually need cron or crond or @cron or any of those alternatives to run things automatically. If you have a program that you want to run at specific times or at specific intervals, you can do that using something called systemd timers. Now, I like systemd timers myself in the context of I'm already running systemd, so I might as well use timers instead of adding another program running onto my system. The initial setup for a systemd timer is a little bit more complicated than a cron entry. Traditionally with cron systems, you would have a single line of configuration you would put in a file somewhere. With systemd, if we want to run a program, we're basically going to have 3 different files that we need to touch. The first one is a script file to actually run. Now, if you've got a program that you're calling directly, you don't need a script file, you can just point to the program. But in my case, I usually want a specific script to run on a timer. So we're going to make a script first, then we're going to make a systemd service to start the script, and then we're going to make a timer to start the service. So it's 2 systemd unit files that we'll need. But the reason I'm making this video is because it's really not as complicated as you might think if you've never done it before. So I wanted to just show you the process in case you ever want to do this. And without further ado, we'll cut to the desktop. Alright guys, so here we are on the desktop using a Fedora 32 virtual machine, and we are going to keep it very simple today. We are going to make a script file, then we're going to make a systemd service to start the script file, and then we'll make a timer to run the service like I explained before. So first of all, the actual script file itself that we'll be running, I'm going to make this inside of our /opt directory. That's a good place to put third-party tools and scripts that you're running. So I'm going to put this in opt, and I'm going to call it myscript.sh, and we'll open that up. And we'll start it off here with crunchbang bin bash. And this script is going to echo some text into a file just to make things easy for us to demonstrate here. We're going to echo the date is, and then we're going to run the date command so that the actual date will be echoed into this file. And we are going to put that into home Jacob documents mylog.log. So I'm currently signed in with the Jacob user, and I want this to go just into a log file within my documents folder. So this script wouldn't be super useful in the real world, but it is going to be very useful for us here to verify that our timer's working, because when the timer gets called, we should log the time and the date into our log file. So I'll save that, I'll close that, and we do need to mark that file as executable. So we'll do chmod +x opt myscript.sh. And then just to test that the script itself works, we are going to open up our documents folder here. You can see right now there's no log file, but I am going to just run opt myscript.sh, and you can see it puts a log file in our documents folder, and that log file includes the date is, and it's the current date. I'm going to run that one more time, and you can see that it is on every execution going to append. Since I used 2 carets in that echo command, it will append the date to the file every single time that that's run. So that's working well. I'm going to throw the log file down in the corner here. So next up, we want to make the systemd service that is going to call that script for us. And it's going to be a very easy service to make. We're going to put that in etc systemd system, and I'm going to call it myscript.service. You can call it whatever you want. It should probably have something to do with what the script is doing. So inside of this script, we are going to start off with our unit section. And the only thing we need to put in the unit section is our description of the service. So I'm going to put description, my custom script. The next section we're going to put in here is the service section, since this is a service file. The type is going to be simple. You don't actually need to put this line because the default type is the simple type, which is basically just starting a process. And then as soon as the process has started, systemd considers it successfully executed. It's not going to track how long it's running or anything like that. I like to include the type even when it is simple, just to make my files easier to read. Next, exec start. This is the file that we're going to call when we actually start this service, and that's going to be opt myscript.sh. And finally, I'm going to put user equals Jacob. So once again, this is the current username that I'm signed in as. If I don't put user equals Jacob, the script will run, but it would be run as the root user, since that's the default user to run systemd services as. That's not a security flaw because it requires root access to enable their start services. So it makes sense that if you've got root access, you should be able to run your services as root if you want to. But in this case, I want to be able to open my log file up. I would be able to read it even if it was created by root, but I just want that to be owned by my user here for simplicity, so I'm including the user line. Now, if we were just making a systemd service and we wanted to run this every boot, we could do that very easily. If you want a log of every time your system boots, we can put a little install section down here, and we can say wanted by equals, and then the target that we want this to be run with. So if I put multi-user.target, then the service, when enabled, would run whenever the multi-user target is starting. If I wanted it to only run when I'm starting the GUI, then I can put graphical.target. Graphical.target is what I normally use when I want services to actually run on desktop computers on startup. But in this case, we actually don't need an install section at all because we're not going to enable this service. If we enable the service, it would start along with a target, but that's not what we want. We want the service to start on a timer, and in order to do that, we need to have the timer unit in addition to the service unit. So I'm actually going to get rid of the install section altogether, and I'm going to save this service. So that's all that our service file really needs to be. Like I mentioned before, this can seem overwhelming if you've never done it before, but really it's 7 lines of text. We're only using 4 options here out of the many possible options that you can put into a service file. So that's all we need to do inside of there. At this point, we can actually test that our service file is working by starting the service manually. Now, we can't enable the service because it doesn't have an install section, but we can start the service manually. So I'm going to do sudo systemctl daemon reload, and that's going to scan for new and updated services. And then I'm going to do sudo systemctl start myscript.service. I'm going to run that. And you can see if I click into our log file down here, it says log file has changed. I'll reload it. And you can see there's a new entry from 9:42 p.m., which is right now. Now it's 9:43. So we know that our service file is working now. And all that we have left is to actually put the timer in place to automatically run that at the interval that we want. So in order to do that, we'll do sudo gedit etc systemd system myscript.timer. Now, it's recommended that you name the service unit and the timer unit the same thing before the file extension. It is not required, and I'll show you how to not do that if you want to. So our timer unit is going to look like this. We still need the unit section at the top, and once again, we'll put a description, and I'm going to make the description the same, my custom script. And then instead of a service section, in this file, we're going to put a timer section, since this is a timer unit. Now, inside the timer unit, if your timer and your service are named the same thing, you do not need to include the unit option because it's going to default to running a service that's the same name as the timer. However, if for some reason you do want to make a timer that's named something different than the service, then you can put unit equals, and then I'm going to put my script timers.service. And just like the type equals simple that I put in my service file, even when I'm making timers that run similarly named services, I still like to include the unit equals option just to make these easier to read. If somebody's unfamiliar with systemd and they don't know that a timer is going to automatically run a service with the same name, then if they're looking at a timer unit, they might be confused about its relation to the service unit. So it's just an extra line of text that you can put in there to explicitly state when this timer runs, we want to start this service. Next up, we get to tell systemd when we actually want this timer to run. Now we can specify a real point in time that it's going to run at, or we can specify a time in relation to when the system was started. So for instance, if I wanted to start this timer 5 minutes after my system booted up, I could put on boot sec equals 5 minutes. So that's going to wait 5 minutes after the system boots, and then it's going to run the timer. And then let's say I also want to run it every 15 minutes after that first run, then I can say on unit active sec equals 15 minutes. So once again, this would mean the system boots up, 5 minutes later this runs for the first time, and then 15 minutes after that it runs again, and then 15 minutes after that it runs again indefinitely. So if you're doing something that doesn't actually have to do with the specific time of the day, but you just want something to run every so often, this is how you would do that. Now in my case, like I said, I want to run this every Thursday. I'm going to pretend, even though this is just a script that's printing the date to a file, I'm going to pretend this is the timer that I'm setting up for the live stream service that I mentioned. Every Thursday, that live stream that I do starts at 6 p.m. So I want to start the stream server up an hour before that at 5 p.m. just to make sure everything on the stream server itself is ready to go by the time that the stream actually starts. So that means I want this to run every Thursday at 5 p.m. And in order to do that, I'm going to put on calendar equals, and the format that we're going to use here is day of week, year-month-day, hour, minute, second. Now, this is one of those pieces of configuration that it's kind of arbitrary, the format that we're actually using here. It is logical. It goes from least specific to most specific. And so in our case, once again, Thursday, I want this to run regardless of the actual date. So I'm just going to put wildcards for the year, month, and day. It doesn't matter what year it is, doesn't matter what the actual date is. If it's Thursday, I want to run this service. And then the time that we want it to run in 24-hour format. So we're going to use 1700 hours. Now let's say that you want something to run the 5th day of every month. If you don't actually care about the day of the week, because the 5th day of the month might be a Tuesday, might be a Monday, might be a Saturday. If you wanted to, you could just put a 5 here in the date field, and if I specify Thursday and the date of the 5th, it's only going to run if it's the 5th day of the month and a Thursday, which might not happen all that often. If you don't care about what day of the week it is, you don't actually put a wildcard here, you just leave the day of the week out. If you want it to run, say, the 5th of every month or every day of January of every year. If I want this to run every single hour of every day of every week, I could do that very easily. But once again, I'm just going to set this back to every Thursday at 1700 hours. Now, when we're using on calendar for real times on the calendar, we also have an option called persistent. And this is a true or false. I'm going to set it to true. The default is false. If persistence is set to true, then if the system was turned off when this would have run, then the timer will run the service on boot. So let's say that I'm wanting to run this at 5 p.m. on Thursday. If the computer was turned off at 5 p.m. on Thursday and then I turn it on at 5:05, the stream still starts at 6, so I'm going to want to run the service as soon as the system starts up. So I would set persistence to true so that if the system was turned off at 5 o'clock and then I turn it on a few minutes later, it would run the service. So that's useful to have. And then finally, we want an install section here in our timer. And I'll say wanted by equals, I'm going to put timers.target. Now this is a default target that's present on systemd systems. Timers.target is a target that starts up during boot automatically. And timers.target is a dependency of basic.target. So every time the system boots, timers.target is going to start pretty early on in the boot process. It's going to start before multi-user.target or graphical.target. If you wanted to, you can make your timer depend on graphical.target if you want the timer to actually start when the GUI starts. So let's say that you were using that on boot sec equals 5 minutes. If you have your on boot sec equals 5 minutes and you set wanted by to graphical.target, it's going to be 5 minutes after the graphical target starts, whereas timers.target is going to be 5 minutes after the timer's target starts, so probably a few seconds earlier. And this is everything that needs to go into our timer unit, so I can save that. and I'm going to close it. Now, two things need to happen for the timer to actually be active, because right now it still wouldn't run at 5 p.m. on Thursday. The first thing that needs to happen is we need to enable the timer. So if I do a systemctl daemon reload, and I forgot to use sudo for that one, so it's asking me for my password. Once I do that, if I do a systemctl status myscript.timer, you can see that the timer is inactive, so it's not running right now, and also it's disabled, so it's never going to run automatically. So what I want to do is a sudo systemctl enable on myscript.timer. And I do have to specify the .timer here. If I don't, it's going to default to myscript.service. If I try and run this, it's going to give us an error because our service file, if you remember, I did not put an install section in it. If you did put an install section in it when you don't need it, it wouldn't hurt anything once you get the timer set up, but you might get confused if you accidentally enable your service instead of your timer. So that's one of the reasons when I'm making a service that is only going to be called by a timer, I don't put the install section in it. So we need to run the enable command on myscript.timer, and once we do that, then we can run systemctl status myscript.timer again, and you can see now it is enabled. However, at this point it is still inactive, it's not running. Next time we start the computer, when basic.target starts and it starts up timers.target, then this timer would be running. So I could reboot the machine right now, or what would make more sense is just to start the timer with a sudo systemctl start myscript.timer. That way I don't have to reboot, and if I run systemctl status, you can see it is active and it is waiting because the timer is not running right this second. So at this point, everything is set up, and at 5 p.m. on Thursday, this timer is going to start my service, which is going to run my script. Now it's currently Sunday night, and I don't want to wait 4 days to proceed with this video, so what I'll do here is I'm going to open up the GNOME Clocks app. Just going to go ahead and add a clock here so we can see what our system thinks the current time is. And I'm actually just going to change my system's time so that it thinks that it's 5 p.m. on Thursday. That way we can test that this timer is going to work. Now, if you just want to test if your syntax is correct for the onCalendar command, there's a handy command that you can use, and that is systemd analyze calendar, and then you put a string with your calendar event. So Thursday, every year, every month, every day at 1700 hours. If I run that, you can see it says from now, 3 days left. That's going to be the next time that this particular point in time is reached. So I know that in 3 days, I've got all my configurations set up. The analyze command is telling me that this string is going to happen in 3 days, and this is the string I used in the timer, and the timer is waiting. So I know that everything's going to work. But just to actually see it in action, I'm going to run sudo timedatectl set ntp false first to keep my system from automatically correcting its time after I change it here. And then I'm going to run sudo timedatectl set time. I'm going to set the time to Thursday, 2020 6/11, so that's this coming Thursday. And I'm going to set the time to 17:59:30 Mountain Time. So I'm going to run this, and you can see our clock changed. It's currently 17:59, and at this point, within 30 seconds, looks like the system was trying to correct its time again. But if I come over here to our log file and I click reload, you can see we do have an instance logged. I see what happened here. So I accidentally put 5:59 p.m. when I should have put 4:59 p.m. because the timer's set to run at 5. Now, because I had persistence enabled, the system basically said, okay, well, we somehow skipped over this time, so we're going to go ahead and run the timer. So that's why we have an instance of this timer running at 5:59:30, because it was supposed to run at 5 p.m. Now, I want to try and get this to actually run at the time that it's supposed to run at. Now, looking at my logs here, I'm not sure what actually changed the time back to 22:06 after I set it. We can see this is where I changed the time to 5:59 on Thursday. The kernel sees that we changed the time, and so does VirtualBox. But by that point, we had already changed it back. All right, so I'm just going to go ahead and stop the service that is doing that, then sudo systemctl stop vbox service.service. So hopefully now, that process is inactive, and I'll set the time this time to 16:59, so that's 4:59 p.m. on Thursday. So I'm going to run this command, and our time has been changed. We can see in our log file that nothing has been changed yet because we have to wait the 30 seconds for it to tick over to 5 p.m. But as soon as that happens here, you can see that our log file was touched again, and now we have a new log entry for 5 p.m. right on Thursday the 11th. So it's actually a good thing I messed that up the first time, because that kind of shows us what persistence does. And as you can see, we now have a timer running that at 5 p.m. at every Thursday is going to run this script and write to this file. So I hope this video was helpful to you guys. I know personally I stayed away from systemd timers for a long time, like a lot of other parts of systemd, just because I thought they were kind of complicated. I knew that I could use the functionality if I knew all the ins and outs, but for a while I never took the time to just sit down and look up how to actually do it. If this video was helpful to you, consider joining the Nerd Club at nerdclub.knots.co for just $3 a month to help me make more videos. But for now, I'm Jacob Kaufman, I'm the Nerd of the Street, and I'll see you guys in the next one. Bye.